Hey guys, I'm continuing straight on from the previous video. So we're now up to using the boundary conditions to find the unknowns. So let's look at our problem. For our problem, we need to have 4 boundary conditions, and the reason is because we have 4 unknowns, C1, C2, C3, C4. We need to establish 4 different equations to solve 4 unknowns. So the first boundary condition is at x equals 0, we have 0 displacement because of that pin joint there. So boundary condition number 1, at v of 0, so x equals 0, we have 0 displacement. I'm going to rewrite that as at x equals 0, v1 equals 0. So at x1 equals 0, v1 equals 0. It's important just to have that notation there to know which formulas we're going to be dealing with. So, for that case, we would be using this formula here, EIV1, so on and so forth. So, if we were to substitute in the required values, we would find that EI of 0, so subbing in for 0, would equal, subbing in 0 there, it's going to be 0, subbing in for 0 there, it's going to be plus 0, plus C2. So you can see that C2 equals 0. So there you go. There's the first constant we've found. The second boundary condition we have is that at x2 now, at x2 equals 10 meters. So you can see that x1 doesn't even reach 10 meters, but the x2 one reaches 10 meters. So at x2 equals 10, similarly, the displacement is 0 because of the roller joint there. So at x2 equals 10 meters, v2 equals 0. So we need to sub that in to this formula here. So we're now dealing at cut 2. We need to sub it in here. So let's try to do this neatly. So we would have 0 because it's equal to 0, 100 outside of 10 squared